In this video, we're going to talk about multiplying polynomials. These problems are like those from 12.5, numbers 31, 33, 37, 45, 47, and that'll be it for right now, because we are going to come back and talk about other special types of multiplication later. First problem is x plus 7 times x plus 5. When we multiply like this, one of the ways that we can look at this is x times x plus 5 plus 7 times x plus 5. X times x is x squared plus x times 5 is 5x plus 7 times x is 7x. 7 times 5 is 35. Then we're going to combine our like terms that are in the middle here. 5x plus 7x is 12x plus 35. This is the standard way that internationally we would talk about this. However, when I have a binomial here times a binomial here, in English-speaking countries, we have an acronym that we call FOIL. That stands for first, outside, inside, and last. So if I would look at the binomial here and multiply the first terms, x times x would give me x squared. X times 5 would give me 5x. 7 times x is 7x, and 7 times 5 is 35. And it just helps me skip this double distribution step. That's my right here on this line. You would just go straight from that line to that line. And you probably learned FOIL if you went to school here in the United States and you took algebra 1 or algebra 2 here. You probably talked about the FOIL method. Again, that's an acronym that only works in English. It doesn't make sense to people who are non-English speaking. So be careful when using acronyms like that there may be a language barrier when you're trying to explain to somebody else. So a plus 8 and a minus 2. We'll go ahead and FOIL this like we just talked about. A times a is a squared. A times negative 2 is negative 2a. 8 times a is a positive 8a, and 8 times negative 2 is negative 16. Combine these like terms in the middle. If you don't like that, you can put your double distribution step in here. A times a minus 2 plus 8 times a minus 2, and you'll get exactly what I have here. One more binomial times binomial before we get to a binomial times a trinomial. 6x squared plus 1 times 7x squared plus 5. 6 times 7 is 42. X squared times x squared is x to the 2 plus 2 is 4. X to the 4th. 6x squared times 5 is 30x squared. 1 times 7x squared is 7x squared. 1 times 5 is 5. 42x to the 4th plus 37x squared plus 5. Now, we don't always have a binomial times a binomial, so FOIL isn't always going to work. We are going to have to use our multiple distribution technique. Now, there's a way, though, that students learned here that they called it a rainbow or something like that, that they said that they're going to take this, multiply it to all of these things, then take this one and multiply it to all of these things. But that just gets messy with all the arrows for me. So I want x times x squared minus 6x plus 3 minus 7 times x squared minus 6x plus 3. X times x squared is x cubed. X times negative 6x is negative 6x squared. X times positive 3 is a positive 3x. Negative 7 times x squared. I'm going to line it up underneath it to keep it lined up here. Negative 7 times negative 6 is a positive 42x. And negative 7 times a positive 3 is a negative 21. Getting you used to this idea here of lining up your like terms because of how we're going to do the next problem. Nothing says you can't line up your terms like this when you are multiplying horizontally like this. But we're about to multiply vertically and use some of the same principles that we had when we multiplied big numbers vertically. So we're going to multiply polynomials vertically one time. And you're going to see the advantage of getting the like terms lined up like that into columns. So the problem starts off with x plus 3 and has x cubed minus 5x plus 6. I'm going to write the one with more terms on the top and the one with less terms on the bottom. 3 times 6 is 18. That's a positive 18. 3 times negative 5x is a negative 15x. 3 times x cubed is a positive 3x cubed. I'm leaving some space in case there's an x squared term here. So there's a 0x squared as a placeholder here. X times 6 is a positive 6x. X times negative 5x is a negative 5x squared. X times x cubed is x to the 4th. There's a 0x cubed here. 18 plus 0 is 18. Negative 15 plus 6 is a negative 9. 0 minus 5 is a negative 5. 3 plus 0 is 3. And bring down that x to the 4th. And we have our answer there. That would have been the same thing as if we would have taken x times x to the 3rd minus 5x plus 6 plus 3 times x to the 3rd minus 5x plus 6. And this first here would have given us this second row, and this second part over here would have given us this top row, and we would have had to combine our like terms and we would have gotten the same answer. It just makes sense though to shift over to your next term and multiply, and to use this method that we're used to with multiplying and lining up things in the columns where the terms are alike, that we have had since a long time ago, maybe 4th or 5th grade, something like that. So that's it for multiplication of polynomials in general. We're going to come back next time and we're going to start to talk about some special multiplication techniques for when we have a perfect square. So we'll see you for that video when we take a binomial to the 2nd power and we end up with what's called a perfect square trinomial. See you for the next video.